It's a pleasure for me to introduce Joe Halpern. Joe has done so many things in his career. I mean, he's got the Dexter Award, the Causal Award, he's a Guggenheim Fellow. He worked in many areas. He has a book on knowledge, which is very influential. He did work on multi-agents and on logic and computer science, and many other things that I don't quite come to my mind, but really many faceted research with a lot of impact. And in recent years, he's been working on causality, and he's bringing up some very kind of insightful aspects to the questions of causality, and I'm very curious and curious. Thank you.
So I'm trying to figure out what I could talk about at this workshop, because I don't do machine learning, despite all the other things apparently that I do, and I definitely don't do interpretable machine learning. So I have some older papers which I sort of updated for a book on causality and explanation with Judea Pearl. And so I thought that might be appropriate because I think of an interpretation of a machine learning program as sort of an explanation of what it does. So really, this is almost a philosophy talk. What does it mean for something to be an explanation? So let me define explanation like defining causality. They're hard. People have been trying for literally millennia. I mean, classic results in computer science are like 20 years old. Classic results in philosophy are thousands of years old. This is classic stuff in philosophy, right? And the way philosophers work, and unfortunately the way I'm going to work too, because I'm a mathematician. At heart, I'd love to be able to prove a theorem that says I have the right definition. If I only knew what the statement of the theorem was, maybe I'd have a chance of proving it, but I don't even know what the theorem should say. So the way people work is, you throw out a definition and then all the philosophers go to work trying to shoot it down. So basically, I'll be talking about a definition of explanation that involves causality and knowledge, and to talk about partial explanations and various notions of partial explanation. I'll go fast because I haven't got much time, but there's a lot more to be said. So the basic idea is that an explanation is a fact that, if it were true, would constitute a cause of the thing you're trying to explain. So, people have been working on this for years. In the philosophy world, people like Hempel and Wes Salmon, they give definitions of explanation that don't involve causality. I think they're wrong. I mean, I think that our intuition about explanation involves causality. And they talk about things, and roughly speaking, they say an explanation consists of some conditions from which the conclusion logically follows. Then they give statistical versions that said it follows most of the time. Van Frassen and Jardenforsch talked about the explanation of raising the probability of the explanandum. Remember, the explanandum is the thing you're trying to explain. And because these definitions didn't take causality into account, they broke on distinguishing correlation from causation. So we don't want to say the barometer falling rapidly is an explanation of the storm approaching, even though it raises the probability. It's correlation, not causation, right? So what about the knowledge part? So this is a point that was observed by many people, probably most cogently by Bas van Frassen. What counts as an explanation for one person might not count for someone else. So suppose we're trying to seek an explanation of why Mr. Johansson has been taken ill with lung cancer. Some possible explanations. Well, he worked for years in asbestos manufacturing. That makes sense if you know that asbestos causes you to get lung cancer. And another explanation might be a causal model describing the connection between asbestos and that asbestos caused lung cancer. And I'm giving you a model in which asbestos causes lung cancer, right? So you know that Mr. Johansson worked in asbestos manufacturing, but you had no idea that asbestos was connected with lung cancer, right? So the point here is what counts as an explanation depends on what you know already, right? So let me just briefly talk about causal models, at least causal models a la Halpern and Pearl. So a causal model for us is a tuple that consists of what we call exogenous variables, endogenous variables, and equations. Let me explain. So this is going back to David's talk this morning. When we talk about a model, the first thing you have to do is say, what are the variables, right? So U and V are sets of variables. The exogenous ones are ones we take to be beyond the agent's control. They're given. That's the way the world is. And the endogenous ones are the ones that we can intervene on intuitively. And then we have equations for each endogenous variable. There's an equation that tells you how it gets its value as a function of its parent. So think of a Bayesian network. I'm assuming you're all familiar with Bayesian networks. So, variable X depends on variable Y. If Y can affect the value of X, intuitively think of Y as a parent of X in a Bayesian network. And we're going to focus on acyclic models where we really have an acyclic dependency relation. We don't have X affecting Y, which affects Z, which affects X, right? So a context is a setting of the exogenous variables. Remember, the exogenous variables were the ones that we take as given, that are beyond, this is just the way the world is. So I'm telling you, the world is this way. These are the values of the exogenous variables. And if I have an acyclic network, once I fix the exogenous variables, think of them as being at the top of the Bayesian network. That forces the values of everything else below, because I've got equations that tell me the values of each variable that's not at the top as a function of its parents. So once I set the parents, that fixes everything else. So just a teeny bit of logic notation. I promise there won't be very much. I'm going to say, value of Y is 3 in this model and context. Remember, a model gives you all the equations. Once I fix the values, the variables at the top of the Bayesian network, Y is going to have the value 3. And this is the only interesting clause. If I were to intervene and set the value of X to 3, that's how you should read this, then phi would be true. And that's true if you start out in a model M. Let's look at a new model where ignore whatever equations you had for X. Again, think of X as an endogenous variable. It's in the middle. But now I'm going to replace, it used to have an equation that said X is equal to Y plus Z. Throw out that equation. Replace that equation by a new equation that says X is 3, or X is whatever little x is. So that gives you a new model. And that new model sort of broke the connection between X and its parents, because you intervened on X and set it to a certain value. And I'm going to say, well, in that new model, where you intervened on X, phi is true, whatever phi is. If that's true, that's what it means for this. So roughly speaking, you should think of when X gets 3, phi is true means after intervening to set X to 3, phi holds, right? And this model, M sub X gets 3, is the causal model that results when you set X to 3. Does that make some sense? Okay, that's the background of causality. Just a few examples, and I'll talk about explanation. So imagine you have 2 arsonists. They drop lit matches in different parts of a dry forest, and both cause trees to start burning. And we can imagine one scenario where one match is enough to burn down the whole forest. And the second scenario, you need both matches. You need to get both trees burning to get the forest to burn down. Okay, we would model both scenarios using a Bayesian network like this, where U is the exogenous variables. That tells you, what determined whether or not the arsonist dropped a match. Whatever external factors determined whether they dropped a match, that's all encoded up in the U. ML1 is a binary variable, it's either 0 or 1. It says arsonist 1 dropped a match. ML2 says arsonist 2 dropped a match, yes or no. And this is the forest burns down. The difference between the disjunctive scenario and the conjunctive scenario is just in the equation for FB. In the disjunctive scenario, FB is the disjunction. It just takes one match to get the forest burning. In the conjunctive scenario, FB is the conjunction. You need both guys to drop matches for the forest to burn. Right? So that's how we model this stuff. All right, so I've written a bunch of papers on a notion called actual causality, which I won't talk about here. It's a different talk. I've given that talk a lot of times before. I wanted to give a different talk. For explanation, it seems that we need a stronger notion that I'm going to call sufficient causality. So roughly speaking, so by the way, x with a vector sign on top is a vector of variables, right? So when I say x equals 3, I really mean x1 equals 2 and x2 equals 3 and x3 equals 7. That's what this is saying. Is a sufficient cause of phi if not only does it bring about phi in context U, roughly speaking, it brings it about in all contexts, so that no matter what values the exogenous variables have, no matter what setting you find yourself in, if you set x to 3, that's going to be enough to force phi to be true. That's the intuition. So formally, sorry, there is formalism here. I'm going to say that x gets x is a sufficient cause of phi. Well, first, they're both true. We would never say that A is a cause of B if, in fact, A and B didn't happen, right? That's just not the way English works. So that's sort of a trivial clause. So there's a more complicated version. Let me give you the not quite right, but easier to understand, simple version. That I'm going to say setting x to 3 is a sufficient cause for phi to be true if I were to set x to something else, like 5, and I set some other variables to y, then phi is false. So roughly speaking, it says if x had a different value, phi wouldn't be true anymore.
Can I ask a
Sure,
small question? This, like, in all contexts,
yeah, that's coming.
seems super strong, and maybe I'm anticipating, but just to, I guess, the example that just pops into my head is something like, let's say somebody gets COVID and dies.
Right.
In some sense, like, COVID doesn't cause people to die in all contexts.
But maybe almost all.
And not even, and yet it seems somehow, say it's 30% of people, but the people who just otherwise would be really unlikely to die.
So we're going to get to weakenings because I agree it's super strong.
Okay, thanks.
So I'm not arguing with that statement. Here comes the all context part. That if x were 3, then phi would be true no matter what the context was. And Zach is going to say, really? You're really in all contexts here? And I'm going to say you're right. I probably don't want to say for all, but let me start with this. And then there's a minimality condition that you don't want to throw in extra conjuncts like x7 is 2 when you never needed x7 to be true to get the other conditions to hold. So let me give examples. In the destructive forest fire example, both ML equals 1 and ML equals 2 are sufficient causes. All you needed was one match to start the fire, right? That's what I told you. In the conjunctive forest fire example, it's the conjunction of sufficient cause. You needed both matches to start the fire, right? All right, now I can finally say something about explanation. So the definition of explanation is relative to an agent's epistemic state. Those are big, fancy philosophical words. Let me explain. For simplicity, let me assume the agent understands the causal model. There's nothing that I'm saying here that depends on that. Just makes it easier to present. So what is the agent uncertain about? The agent is uncertain about what the context is. What actually, was one match dropped? Were both matches dropped? What happened? Right? I know the way the world works. So there's two sources of uncertainty in general, right? There's the way the world works. That's the equations. That's the causal model. Does smoking cause cancer? You might not know, right? How does COVID work? You don't know. You don't know the causal pathway that goes from, getting COVID to die, right? And the other thing you could be uncertain about is what actually happened. Were you at a party where there was a super spreader event or something like that? Was one match dropped or two matches dropped? Right. So I'm going to, for simplicity here, assume that you understand the world, the way the world works. That's the part about assuming the causal model is known. So your uncertainty is a set of contexts. The contexts, remember, are the settings of the exogenous variables with a probability on them. So you can talk about it's much more likely that 2 matches were dropped than 1 match was dropped. Right, are we together? I mean, I'm not saying anything deep here. So I'm going to say x equals x is an explanation of phi relative to k. So again, what counts as an explanation depends on what you know or believe. If x equals x is a sufficient cause of phi, that was the previous definition, but I'm going to restrict the contexts in k that satisfy x equals x and phi. So I'm basically tossing out contexts where it's not the case that x equals 3 and phi is true, because I'm only trying to explain phi. But I could say a lot more about each of these, but I want to get through this fairly quickly to give you a sense of how the definition works. So again, x is minimal. There's no strict subset that works. And there's a context where, in fact, x equals x and phi. I mean, I don't want to say if my knowledge precludes phi being true, then what does it mean to explain phi? As far as I'm concerned, phi is impossible. Right? So I have to think it's possible that phi happened. And I have to think it's possible that x equals x happened. Otherwise, I can't possibly say that setting x to 3 was a cause of phi, right? So think of k as sort of the support of your beliefs. It's the set of contexts that you assign positive probability to. So the disjunctive forest fire example, if uij is the context where, so I and j are 0 or 1, so ML1 equals I and ML2 equals j. If it's like 0, 0, it says neither guy dropped a match. If it's 1, 1, it says that both guys dropped matches. So there are 4 possible contexts depending on the settings of I and j. So suppose you think all 4 possibilities, you have no clue who dropped a match, maybe none was dropped, right? Then both ML1 and ML2 explain the fire. Right? If you just go through all the definitions, each of them is a sufficient cause, and you think they're both possible. So you see a fire, you say, well, it could have been that agent 1 dropped a match, could have been that agent 2 dropped a match, maybe both dropped a match, right? These are all things that could have happened. Now, both dropping a match is not an explanation because it's not minimal, right? So each one, agent 1 dropping a match is an explanation, agent 2 dropping a match is an explanation. The conjunction is not an explanation because of the minimality condition. I don't need to, one of them's enough. But if I only think it possible, if I'm sure that agent 2 didn't drop a match, agent 1 I'm not sure about, but agent 2 I'm sure did not drop a match. That's what this is saying. The only worlds I consider possible is agent 1 dropped a match, didn't drop it, neither one dropped a match, or agent 1 did and agent 2 didn't. Right? Well, in that case, ML1 equals 1 explained the fire, but ML2 equals 1 doesn't, because I don't think it's possible the second guy dropped a match. I'm convinced he didn't. So it can't be an explanation. Right? So let me get to the interesting stuff, partial explanations. And Zach, here's where I'm going to address your point. And I'm not going to address it completely, but I think your point is well taken. So, so not all explanations are equally good. There are different dimensions of goodness. And I want to talk about a few of them here. Simplicity, generality, informativeness. So let me mention 3. So EX1 appeals to sufficient cause, right? I mean, the first clause said x equals x is a sufficient cause, right? And thus requires SC2 and those conditions hold for all contexts. This is your point, Zach. Well, what if it only holds for most contexts or the most significant ones in some notion of significant? So here I can talk about probability. So I can say, but I think Zach is right. So let me just say that I will model most using probability. But I think so I can talk about the probability that an explanation satisfies SC2 and SC3 is just the probability of the set of contexts where those conditions hold. It doesn't hold for all of them. It holds for most of them in a probabilistic setting. So I can talk about the goodness of an explanation. Alpha and beta are numbers in the interval 0, 1. And it's the probability. It says that SC2, the second condition, I can go back to conditions, but it's not the point. That I have these conditions that are required to hold for all contexts. And this says it holds for a set of contexts with probability at least alpha. And the third condition holds for a set of contexts of probability at least beta. So this is a probabilistic notion of goodness. But let me come back to Zach's point that when we look at people, somehow we have some notion that this is like the typical setting, not a probabilistic notion, but somehow COVID typically causes cancer, or typically causes, this spike thing typically causes it, or something like that. And we don't exactly mean probability. So thinking about alternatives here, I think might be useful, but this is as close as I get to answering your question, Zach.
Also, even from a probability perspective, there's not just the question of how high it raises the probability to, but also sort of what was the baseline.
This isn't how high it raises it to exactly. It's what is the probability of these conditions hold it?
So can you repeat questions for the?
Oh, sorry. Zach said it might not just be a question of how high it raises the probability to. And I just want to play on words a bit. That I'm not talking about raising the probability of anything. I'm talking about the probability that conditions hold. Right. So it's not that these conditions raise the probability from 1/2 to 3/4, which was the old. I mean, people like Salmon had notions of explanation that had that flavor, and that's not exactly what I'm saying.
I guess what I'm kind of getting at something like I said, there's the fact that if you took a normal person on a normal day who didn't have COVID, the probability that they died that week or that month or something, it looks like you add on that someone has because their baseline belief is the typical person in a typical month is not going to die.
Right. So let me repeat that Zach was talking about rather than just looking at a probability over context. Let me put a gloss to tell me if I got it right. That we have some notion of typicality that a typical week or typical month as our baseline, this person won't die, and he did. And that's what we're comparing it to. And I agree with that. And this is not capturing it quite. So it's I think. So let me say that I'm going to give you 3 examples of closeness, if I can get it, squeeze it in the next 5 minutes. This was the first. The other 2 are different, so they won't address this issue either. But these were meant to be sort of examples of the kinds of things you could do. I think the framework is rich enough to let you address these kinds of things. That I think the framework of causal models and definitions like this, even if I'm not doing it, but I don't claim to have done it either, and it would be interesting to think about what the right way is of doing it. Right. Right. Let me keep going, and so I can get done, and then we'll have a whole hour of where you can poke at me all you like. I don't mind being poked at all. So partial explanation, here's an example. Victoria's tanned. I'm looking for an explanation. Why is she tanned? She took a vacation to the Canary Islands. It's sunny in the Canary Islands. She went to a tanning salon. So there are 8 contexts where we have 3 binary variables. She either did or didn't take a vacation. It either was or wasn't sunny, and so on. So we can think of the 8 possible settings of these 3 variables. And maybe going to Canaries is not an explanation of Victoria's tan, because if it's not sunny, she won't get a tan. It's not true that her going to Canaries guarantees that she gets a tan no matter what, if I think all possible settings of these variables, if I assign them all positive probability, right? On the other hand, in almost all of them, she gets a tan or she goes to Canaries. That's a pretty good explanation. So again, so this is the kind of thing we can do. Let me keep going. Shai, how much time do I have according to you? I think I started a little late.
Yeah, 6, 7 minutes.
All right, good. So let me just give you a different flavor, because that's, the point here is I could go into a lot more detail about each of them, but I want to give you a flavor of the kinds of notions we're looking at for partial explanation. So we often prefer the most likely explanation. Again, this is a notion that the people are used to in stats, Bayesian networks, so on. So in the disjunctive forest fire example, so this just says either you think just agent 1 dropped a match and agent 2 didn't, or just agent 2 dropped a match and agent 1 didn't. But suppose I give higher probability to U01, this one, which means, whoops, no, it doesn't mean this. It means just the opposite of this. So I got this backwards. It really should say that ML2 equals 1 has higher probability than ML1 equals 1, but it doesn't matter. that if I give, let's say, this one higher probability, I would say, okay, well, I have two explanations. ML1 equals 1 is a better explanation because it has higher prior probability, right? That's a different notion of better explanation than I had before. But that's not the whole story either. Suppose there's a fire in a lab. You suspect an arsonist, but one of the variables in the model is oxygen, the presence of oxygen. Well, you're sure that there was oxygen. So your set of possible contexts consists only of contexts where there is a fire. And then the fact that there's oxygen certainly is a sufficient cause of there being a fire. So it's an explanation of a fire, right? If there hadn't been oxygen, there wouldn't have been a fire. Not a very good explanation intuitively, but according to my definition, the fact that there's oxygen counts as an explanation of there being a fire. If you just go back and look at all the conditions.
It's just necessary.
Yeah, but if I had the right set of Ks, it would be a sufficient cause as well. So, and the probability of oxygen is high, but we don't view the presence of oxygen as a very good explanation. So roughly speaking, we want to say the explanatory power of a partial explanation relative to your beliefs is the probability that phi happens relative to the explanation. And this is Shai's point. I mean, the oxygen might be necessary, it's not sufficient. What's the probability of there being a fire if there's oxygen? Well, it's actually pretty low, right? So, okay. But this isn't quite right either, because this definition, and going back to Alex's talk, there's the difference between observing phi given that x equals x, and observing and phi being true given that you set x to x. So this definition is confounding correlation with causation, because it's just saying that the phi is quite likely given that x is 3. It doesn't say that x equals 3 is a cause of phi with high probability. So what we really want to do is put in a do in there, roughly speaking. But so these are competing notions of goodness. So I've gone through this very quickly. You weren't meant to understand all this in detail. That would have taken me a much longer talk. But my point here is that there's a tension between these notions of goodness. These are all notions that I claim we use in practice for how good an explanation is. It's not like I made them up to fill out the talk with extra slides. It's, you know, if you look at the literature, people talk about explanations being good on these different dimensions. And as Zach pointed out, I mean, even these dimensions aren't quite capturing what we're saying. But there's a tension because you can't necessarily get all three at the same time. You might have competing explanations. You know, one does well in this dimension, one does well in that dimension. So you have to decide what's important, and I have nothing particularly intelligent to say about how you make the decision. So let me just conclude by saying explanation is an extremely slippery notion, like causality. The definitions that I gave you, and I glossed over some of the details I didn't give them to you quite right, because the way I gave it to you, there's counterexamples. So it's more or less what I said, but not quite. And you know, how do I know I've got it right? And the answer is I don't. You know, I wish I could prove a theorem saying I got it right. I wish I could even prove a theorem saying, you know, here's a bunch of axioms that you absolutely want it to satisfy. I haven't even got that. But you know, so we have examples where people have tried to argue we haven't quite got it right. We fixed up the definition and so on. And the other point that comes up with explanation much more than it comes up with causality is all these competing notions of goodness. And modelers need to trade them off, and they're really quite distinct. You know, I've gone through it quickly, but I hope you got the sense that, you know, you can be really high in one dimension and low in another, and they're incomparable. So you get a partial order on explanations, you know, on how good an explanation is, and you know, what's important to you. And I've only scratched the surface as, you know, a plug, shameless plug for my book, where there's a lot more. So let me stop in the hopes that I've given you at least a bit of time for questions. I'm done.
Any quick question before we take?
Yeah, otherwise we've got a whole hour where you can poke at me and Alex.
And I still have the 5-minute bathroom break. Doesn't mean that anybody goes to the bathroom, but.
While people are going to the bathroom. I just wish I got the likely part right. So given that we know what happened, isn't it the unlikelier thing that is the better explanation?
I see what you're saying.
Like if there's Bin and Shai are hanging out in the forest, and because Shai doesn't believe in causality, he's a chain smoker, and he always lights a match. We're in the conjunctive case. Bin's, however, not much of a smoker. And then there's a forest fire, and it turns out that was one day. In some ways, isn't that like a better explanation because it was?
That's interesting. So
it's the unusual thing.
I see what you're saying, and certainly people have done explanations of causality. Psychologists have done experiments of causality, and people. So the definition says they're both equally. Let's forget about explanation. Let's just look at causality, where we have a fire and both Shai and Bin were smoking. But sorry guys. Typically, Shai chain smokes all the time. No big surprise. Bin, this was like a one time in 10 years where she finally gave in. Wouldn't we count Bin as a better cause in some sense? And so people have done experiments where the kinds of experiments they do is the score in the soccer game was 2-0. And two people scored. One was the high scoring forward who, every game he scores, well, soccer, 1 goal, that's a lot. And the other guy scored like his first goal in the last 5 years. Who's the cause of the victory? And you're right, the people experimentally point more to the guy who, it was the first time he scored a goal in 5 years. So this definition doesn't get at that, let me not pretend.
It's the unusual event that led to the unusual outcome.
So let me give you a better version, which again, I'm more comfortable talking about causality, but the same issues will arise in explanation. So we have a notion of, so there's this really nice experiment due to Josh Nova, an experimental philosopher, and he was working with somebody else's name, I forget. And the story goes as follows, that the department admin has a jar of pens on her desk, and they're supposed to be for the admins, not the professors. But in fact, typically the professors take them just as often as the admins. And on this particular day, there were 2 pens in her jar, and Professor Smith walked by and took one of them, and admin Annie walked by and took another. So when a third person came by and wanted a pen, there wasn't a pen there. Who was the cause of the pen, of there not being a pen?
The professor's fault.
Well, okay, so exactly. So according to our definition of causality, they're both causes, right? It's not, they're both equally good causes. They're just completely symmetric. What do people say? Exactly as you said, Zach. They take the professor, and in fact, when they change the story to say that the pens are supposed to be for the professors, not the admins, because the admins have their own pen supply. They're not supposed to take it from the front desk. They exactly switch and say that the admin was. So it's not likelihood exactly. It's normality and expectation, right? I can even tell you, like probabilistically, the professors take the pens just as often as the admins. So it's really not the probabilistic unlikelihood or likelihood. It's more that the rule is that the professors are or.
It's about causal, it's just blame. It's different. I mean,
I actually agree with you that the trouble is English is not very good at, we have words like cause, blame, responsibility, blameworthiness. I mean, it has a ton of words and we're not very good at distinguishing them. So, I mean, the experiments use the word cause. I didn't run the experiments. They've also done versions of who's responsible, right? And again, I've given a formal, I have other definitions of words like blame and responsibility. I have literally paperwork where I define notions of blame and responsibility, but again, it doesn't match the way people use them. So I totally understand what you're saying. It's not that I'm disagreeing with you, it's that I don't think people make sharp distinctions. So we as, more mathematically trying to give formal definitions, I make sharp distinctions between the different versions. It's really hard to do an experiment to sort of tease out what people mean, because I just don't think they think hard about the distinctions. So, I mean, I think your point is well taken, but I don't know how to answer, because we're talking about how people react. I think it's useful to have definitions that distinguish these things so that we, the modelers, can understand, what do we mean? Even if people don't make the sharp distinctions, I think we should. So I'm all in favor of trying to distinguish these notions, and indeed I have definitions that do. Yeah, another quick one. You should tell me when to shut up, Shai, because I could happy to keep going.
I think I've read at some point like a similar experiment where the question was, so the setup was something bad is happening, like someone goes through like a dangerous area. You take one person goes there quite often, and one person only rarely gets because that happens. And then you ask like about the explanation. Apparently, the person who goes there rarely thinks it's their fault, so it's like kind of attribute the cost.
Right, because
and the other person maybe doesn't, but society would judge it differently. So maybe it's also
that's a fair point. So should I repeat that? Sorry, I don't know your name, but that's
Tosca.
Fresca. Okay,
Tosca.
Tosca said. Tosca said that if we have a situation where one person goes through a dangerous area often and another person goes through very rarely, when they're attacked, now it could be that the person who goes through rarely is more likely to say, "Oh, it's my fault for going there," whereas the person who goes often, "Well, I've gone there tons of times, and I don't really want to attribute me going to the dangerous area as the cause," but society might look at it the other way around. I think that's fair, and again, I'm not quite sure what to say, because I'm actually thinking hard now about what it means for there to be harm. So I have a lot to say about that. This is, I think, somewhat related, but let's not go there. Right.
Let's take a 2-minute break to set up.
So let me just say one thing that this actually goes back to work of Kahneman and Tversky, that they said that when people talk about causality, they're much more interested in undoing the atypical thing than the typical thing. So this is in the spirit of what Zach was saying. So if they have multiple causes for something, what they'll attribute causality to or blame to is the atypical thing, because if they could undo the atypical, but this is what we're trying to get at with our notion of normality, that typical is not necessarily statistically typical, right? It could be, maybe I would say a better word is they try to undo the abnormal thing, and there's various notions of abnormality, as in, going against a moral principle or going against a department rule, going, statistically abnormal. They're all different notions of abnormality.
Was it you who had the great example of like the flowers, of like why did my flowers die? And it's not because the Queen of England failed to board a plane and come over and water my flowers.
That's not my example, but if you have anything credit.
There's an example that a student brought up when we were reading your actual class paper in class. Yeah.
Anyway, I should stop. You guys can take a break, and
Short break.
I'll do that.